Okay, welcome to lesson 8.4, fraction and whole number division, no models. So I'm going to show you today how to solve division problems using a fraction and a whole number without using a model. So there is a trick. Let's see what it is. Before we get into the trick, let's review the models because we did see some very important patterns when we were using models. The first problem I have here is 4 divided by 1/3. So we're starting with 4 wholes. That is our first number in the division problem. And division can mean cut. Division means like split it up. So we're going to split 4 wholes into 1/3 size pieces. So here I've drawn 3 wholes. I need one more whole. All right, and then I need to split them into 1/3 size pieces. So on the very first one, I'm gonna go down and make thirds on that one. On the next one, I will make thirds. And then the next one. And then the last one. So by splitting all 4 of these wholes into thirds, I've made 3 pieces out of each whole. So we've kind of noticed in the past that this means that I now count how many pieces I made. My answer is how many pieces I made. And in the first whole, I have 3. Then I have 3 more, which brings my total to 6. And then I have 3 more, which brings my total to 9, and then 3 more, which brings it to 12. And that's skip counting, guys. Skip counting is multiplication. So even though we're solving a division problem, we are in fact kind of multiplying to find our answer. And we've noticed this pattern that 4 times 3 equals 12. And remember, I also said before that this only works when 1 is in the numerator. But it is important that we see that pattern because it will help us to solve these without models. Okay, another review problem I have for you is where the fraction is first. So in this problem, 1/3 is what we're going to start with. And we're going to divide 1/3 into 2 pieces. So that's what this problem means. 1/3 cut into 2 equal size pieces. So I've drawn 1/3 for you right here. And basically what I want to do is I want to cut this right down the middle and find out how big is this piece. How big? I'm going to draw it underneath so we don't have to go above. Okay, I want to cut right down the middle of this 1/3. And my question is, how big is that one piece? How big is it? So basically, if you think about it, I'm cutting this 1/3 into half. Okay, I'm dividing it by 2, but I'm cutting this 1/3 into half and half. And I need to know what this half is. I need to know what half of 1/3 is. Half of 1/3. Well, what is that? I know how to solve multiplication problems with fractions from the last chapter. So half of 1/3 is 1/6, and that happens to be my answer up here using fraction models. I also used a multiplication problem to help me solve that. Okay, one more thing I want you to remember before we start this lesson. I know I haven't got to the lesson yet, but you need to remember a few things. How do we turn a whole number into a fraction? So let's say I'm given a whole number and my whole number is 5. Okay, 5 wholes. But I want to turn that into a fraction. Maybe I need to multiply it with another fraction, or maybe I need to divide it with a fraction. And so I want to change that whole number into a fraction. Well, what we do is we take that 5 and we turn that 5 into a fraction by putting a division sign, a fraction bar underneath the 5. But the fraction bar is a division sign, so I'm not completely wrong, but we're going to put a fraction bar under the 5, and then we're going to put a 1. This is a placeholder 1. It turns any whole number into a fraction. My class likes to call him Stan. There's Stan. Stan is our placeholder 1, and he turns all whole numbers into a fraction by being the denominator. Okay, so remember this. Let's get to some 8.4. So 8.4, the 3 letters you need to remember are K, C, F. K stands for keep. C stands for change. And F stands for flip. Okay, we need to remember those 3 steps because that is how we are going to solve these without models. Okay, let's look at example number 1. So I have 6 divided by 1/5. I need to remember those 3 letters, K, C, F. Okay, that means I'm going to keep this 6 exactly the same, 6. I'm going to change the division sign to a multiplication sign. And then I'm going to flip the fraction I have here. I'm going to just flip it. I'm going to take the denominator and flip it around and make it the numerator. So instead of 1/5, I'm going to flip it to be 5/1. Uh-oh, that looks very familiar to us. 5/1 is a whole number. So this problem is exactly the same as saying 6 times 5. 6 times 5, I know that answer. It is 30. And that means that my answer up here is also 30. Okay, so there's one example. And all I did was K, keep the first number the same. C, change the division sign to multiplication. And F, flip. I flipped the fraction into a whole number. And then I was able to solve 30. All right, here's one that's a little different. This one has a fraction first. My first example had a whole number first, but I'm still gonna use those same 3 letters, K, C, F. I'm going to keep 1/10 the same, 1/10. I'm going to change the division sign to multiplication. And then 3 is a whole number. How do I flip a whole number? There's no denominator to move to the top. Well, all I have to do is I need to change this 3 into a fraction by putting stan underneath. So now I have 3/1, and now I can flip it. So I'm going to put 1 on top instead. So now I have 1/3. So I'm going to solve this problem. 1/10 times 1/3, and I know how to do that from chapter 7. 1 times 1 is 1. 10 times 3 is 30. So the answer to 1/10 divided by 3 wholes is 1/30. All right. And you're kind of seeing the same stuff. I'm not using models anymore, but when we were using models last time, if we started with a whole number, our answer was a whole number, and that's exactly what I got here. And if we started with a fraction, our answer was always a fraction, which is what I got here. And I'm using multiplication patterns, so 10 times 3 is 30, and over here, 6 times 5 is 30. Okay, I didn't realize I put 30 for both, but that's okay. Let's look at 2 more problems real quick before we are done. All right, 15 divided by 1/4. I'm gonna just, before I solve, I know I'm starting with a whole number, so I'm gonna predict that my answer will be a whole number. You think I'm right? Let's see. Okay, I'm gonna use those 3 letters, K, C, F. And I'm going, that means K means keep 15 the same. 15 is going to stay 15. C stands for change. I'm going to change that division sign to a multiplication sign. And then F stands for flip. I'm going to flip this fraction around. The 4 is going to go on top. The 1 is going to go on the bottom. And it's going to be 4/1. We know that 4/1 is the same as 4 wholes, so if you want, you can rewrite this as 15 times 4, and now I can do that in my head. Well, I can kind of do it in my head. 15 doubled is 30. If you need to do some side work, always do some side work. Always, always make sure you're right. So let's do it this way. 4 times 5 is 20, 0, carry the 2. 4 times 1 is 4. Plus 2 is 6, 60. So 15 times 4 is 60, and that means that my answer up here is also 60. Okay, one more. 1/9 divided by 2. I'm going to use those three letters, K, C, F. K stands for keep. I'm going to keep 1/9 exactly the same. C stands for change. I'm going to change division to multiplication. And flip, or F stands for flip. To flip the whole number, I need to make it a fraction first. So I need to put a 1 underneath it. And then now that there's a 1 under, I can flip it around and it's going to become 1/2. And I know how to solve this. 1 times 1 is 1. 9 times 2 is 18. My answer is 1/18. Okay, so that is how you solve division with whole number and fractions without using models. The method we used is called keep, change, flip. And what we did is we changed our division signs into multiplication signs. We basically solved the division problem using a related multiplication problem, and it was successful. All right, when you are ready, go ahead and put some practice in on the Personal Math Trainer and do your 8.4 quiz. Have a good day.